Since most of you watching probably know us from the CryptoKitties days, I wanted to give you a quick introduction to Flow and why we built our own blockchain. I'll make it quick, but I think it'll be helpful context for the rest of the sessions. First, our mission at Dapper Labs is and always has been the mainstream adoption of crypto. We've always believed that in order for that to happen, consumers need to understand and feel the benefits of blockchain beyond just trading cryptocurrencies. That's why we started with games and virtual worlds. Especially now in a post-COVID world, the principles of digital ownership, of peer-to-peer networks, of sharing in the value that you help create on digital platforms is more important than ever. And demand for these values will bring about a new wave of applications. The biggest brands in the world agree with us. These are some of the partners we've spoken about publicly, but there's more where that came from. I can tell you that almost every major consumer brand is deeply evaluating the impact of blockchain and how they interact with their customers. We're proud to be part of leading that conversation. Today, you'll hear from Katie Tedman, who's our head of partnerships, on how these conversations have been going and what these groups really care about. But I also want to make clear, Flow is a platform that we're building our own IP on top of as well. And you can be the first to hear about CryptoKitties on Flow by being part of that community on Ethereum today, starting to share more on that very soon. As you know, there's some major blockers to adoption when it comes to blockchains. The problem of scalability is itself three problems, right? It's speed, cost, and throughput. But the user and developer experience of building on these networks is even more critical in making them a sustainable foundation. When CryptoKitties broke Ethereum, we spoke to all of the folks working on blockchain scalability, from Vitalik to Dan Larimer, Silvio, the Polkadot guys, you name it. And we realized that the approaches everybody was taking would make things even worse from a user and developer standpoint. That's why we started working on Flow. This is what people that have gone deep into Flow are saying about it today. And in a sense, because we started from first principles, we've solved a lot of the problems with blockchain that are obvious in retrospect, but still not really well understood by most people who haven't already tried building applications and real businesses on top of the technology. And I wanted to quickly walk through those main categories. First, everybody else is pursuing only one of two approaches when it comes to scaling blockchains. On the one hand, Ethereum and most of its competitors are betting everything on sharding. And whether you call it sidechains, whether you call it parachains, the upshot is still the same. You're losing atomicity in the execution environment and breaking it up into smaller pieces. On the other hand, projects like Libra, like EOS, they're sometimes temporarily, sometimes permanently giving up on decentralization in order to increase speed and throughput. We think both of these approaches throw a wet blanket on the value of blockchain, especially to developers. On the one hand, sharding makes blockchains much harder to build on and much less composable. On the other, reduced decentralization creates regulatory problems and doesn't get a core community excited to engage in the applications that are built on top. So we created a new architecture for Flow inspired by how modern CPUs work, really dividing up the tasks that go into creating and validating blocks and having 4 different kinds of nodes, each specialized in one part of the process. That means we don't shard the network and we can keep a shared state, an asset compliant environment, while at the same time having the potential to scale to tens of thousands of nodes and having maximum decentralization. As far as we know, Flow is the only blockchain that works this way, which is why it's taken us 2 years to validate all of our hypotheses and bring you a platform that you can actually build on. And our product lead, Lane LaFrance, will speak to some of the roadmap we've had to date, as well as what you can expect over the next few weeks. On the programming language front, all of the other projects are either just sticking with Solidity and Ethereum Virtual Machine, or jumping ahead and trying to adapt WebAssembly for blockchain use cases. Now, Solidity and EVM have served us really well, but there's not a single smart contract developer that's not frustrated with the difficulties and with the limitations that they place on them. And WASM is amazing, but it's built for the constantly changing and always in flux nature of web applications, not the immutable security that you need when you're writing smart contracts. And so you'll hear about this from Dieter Shirley, who'll do a deep dive today. and tell you a little bit about Cadence, the program language we built from scratch, which is getting a lot of adoption in all kinds of different circles. Now, we think of Cadence as the fastest, easiest, and safest way to write smart contracts. And Dieter will tell you a little bit about why that is. But we didn't stop there. So much of Flow was re-engineered from the ground up so that developers and users don't even have to think about the normal friction that you experience on blockchain today. This is one of the main reasons we invited Sean Lee from Fortmatic here, so you can hear it directly from a CEO that's building a business on top of the platform. But you'd also hear from Katie that big brands are pretty sophisticated about this stuff. And we've had to do a lot of work to make sure Flow stays a good foundation where these folks are comfortable building entire businesses on top of. Last, but maybe most important, I want to highlight that although Flow is working with some of the biggest brands in the world, and although we do expect the first wave of users to come from these brands, we are absolutely committed to an open, permissionless, and decentralized future. That means you, the developer community, should get involved early. You can go today, start learning Cadence on the Flow Playground. You can check out the SDKs and the emulator that we've open sourced on GitHub that should let you start building Flow applications immediately. And then jump into Discord so you can start chatting with the rest of the community and start seeing the kinds of things people are building on Flow. Without further ado, thank you for joining us. We've got a great session ahead of you today. I'll pass off to my colleagues to do deep dives and tell you a little bit more about what we've been working on. Thank you.
Hey folks, thank you so much for having me today. I'm Lane, the product lead for Flow. I've been with the project for quite a while, and I get the opportunity to tell you all about what we've been up to, how we got here, and where we're going in the future. So, as Roham alluded to, there was a pretty extensive landscape review that took place after we launched CryptoKitties. Myself, Dieter, Roham, and the rest of the CryptoKitties founding team were, of course, excited by the success and certainly felt the pains of the lack of scaling approaches. And so we really were struck by the ability for CryptoKitties code to access other code in the ecosystem atomically, and for someone to build on top of our existing CryptoKitties ecosystem and extend it seamlessly without any permission from us. We later started referring to this, as the rest of the community did, as composability, and Flow really was designed with that essence of code building on code at its very core. The ability for projects to address scaling was, as Rohan mentioned, lots of folks had a really solid understanding of dividing out the state, maybe sharding it, adding throughput through smaller proof sizes, state channels. There were a number of really interesting approaches, but we really felt like they were missing the meat of it. They were missing what we thought was really cool, and that was the ability for contracts to interoperate on top of each other. And so we took a fundamentally different approach and thought about what would it take for there to be a decentralized computation network where financial use cases were one component of that, but where it really was about the smart contracts and the computation first. And when we approached the problem that way, we really reevaluated the way the systems were coming to consensus and came to the insight that if you come to consensus on the inputs, the deterministic outputs are knowable. Everything once the inputs are set is observable by other participants in the network. And so you really can, as Roham alluded to in his last presentation, have more decentralization, more participation, and more participants in the areas that are going to contribute to the most security of the network, like participating in the core consensus algorithm. And you can exploit great deals of performance in the deterministic areas of the process without making compromises about security or decentralization. And so that really was the first thing on our roadmap. We built out this multi-node architecture. We built out an MVP. It took the team of about 10 of us 4 months, and we were able to prove out that it really was a faster approach to divide consensus and compute in this way. It was efficient. There was the number of redundant tasks had dropped significantly, and we really were we were quite happy not only with the performance improvements that garnered for the system, but the transition to proof of stake for efficiency reasons and impact on the environment wasn't something that was lost on us. And so we really were quite happy with the efficiency gains that were added to with this. And most importantly, it was secure. And so we really proved out that having the nodes interact with each other in the way that they did, and the balance of concerns and the ways in which they were checking each other's results was going to, in fact, ensure that there was enough checks and balances in the system to maintain security while not compromising the scale of the system and the speed of it. And so after building out that MVP, we of course needed to share our results with all of you. And so we put them into 3 different technical papers. The first one was around dividing consensus and compute and how that idea works. The second was around our use of hot stuff, a consensus algorithm that ensures message complexity scales linearly, which for anyone who's worked in these systems knows that communication really can be the bane of a decentralized network. And the hot stuff paper has been shown to scale to 2 or even 300 nodes. And we felt very strongly that that level of participation was important to the core consensus process. And so Flow really is using the state of the art in what it means for participating in the real security and decentralization of the network. The third technical paper that we put out was got some good attention and feedback from all of you, which is something we really appreciate. There's actually a revision of that paper coming out pretty shortly here that we're excited to share with you. But the third paper, it discusses our mitigation of the verifier's dilemma, SPOCs. So specialized proof of confidential knowledge is what that lovely acronym stands for. And it's a unique scheme for proving that 2 independent actors check the same input. They absolutely both checked it, and that they both came to the same result. And so that, of course, is a really important component for ensuring that the system is fast and accurate. And so that was phase 1. That was phase 1 of the roadmap that took place from about May of last year over the course of the summer. And it was really about answering the question of how do we make it as easy as possible for developers to build for a single community, to ship on a single shared state without adding complexity and cost. And then we moved over to actual computations. So the smart contracts on Ethereum absolutely paved a new wave of innovation. And we wanted to make it as easy and intuitive and stress-free as possible for developers to program with real value. Deet will discuss our decision to build out a new resource-oriented programming language in his talk in a little bit, but what we've shipped to date that I really want to highlight is a couple different things we've shared with all of you. So the first, of course, is the standard implementations for fungible and non-fungible token standards, so the Cadence equivalents of ERC 20 and ERC 721. With that, we put out a web-based development environment to play with these standards and other Cadence features. We call it the playground. We hope to see you in the community. There's been a couple Cadence Cups testing out what you can do there, and folks are having a lot of fun with it. The third thing we put out was an emulated version of the Flow blockchain, so you can actually deploy contracts here locally, submit transactions to them. It's a really helpful testing environment, and it gives you the feel of deploying against the real blockchain without having to run against the actual testnet. And then the fourth thing that we've put out quite recently was the VS Code extension. So a more complete development toolkit for all of you that are excited to build dApps, and our community has really been loving it. And then of course, the last question for us as the usability people is, well, how are you going to onboard users? So just last week, the Flow client library was released as an opinionated implementation of our JavaScript SDK. It makes it really easy to onboard users without dragging them through key management the very first time around. So it's a tool for you as a developer to map user IDs to Flow addresses. And it makes it really easy for you to transition a user from an off-chain to on-chain account when they're ready. It's incredibly straightforward to integrate with. As many of you probably know, integrating with multiple wallets can be quite challenging. And so we've made it as easy as possible to integrate with a single interface that'll expose a number of wallets to you and your users, including, of course, Fortmatic and Magic from Sean Lee, who will talk after this. And so with all of that under our belts, what's next? Beyond just shipping the network, which I'll speak about in a moment, there are 3 priorities for us in the coming year to make sure that the ecosystem around Flow can really flourish. So first, of course, is enabling participation through community validator participation. The protocol, as I've mentioned, is absolutely designed for participation in the core components, and that's something that we're going to be onboarding more of you to in the coming weeks even. And epochs is the term that we use for adding the logic of removing that and adding validators to the protocol state. So that's also something that'll be coming up this summer. Onboarding people to the next generation of software is really about making it as easy as possible for you to bring your users into these experiences. And so onboarding your own users, your family, your friends via methods that they're comfortable with, that they're familiar with, like fiat on-ramps and access to tokens that are backed one-to-one with USD is something we think is really important, and something that the protocol will support very soon after we release it in a short while. Can't wait to tell you more about it. And that's something that was really important to us for ensuring that you could focus, you and the community and everyone else who's building here has the opportunity to really focus on building. And then of course, Cadence. So Deet will, again, he'll chat about this a little bit more, but there's some areas that we're really excited about, including static analysis of transactions so that it's easy for user agents to see what they're signing and show that to their users. Extensibility, so the idea that contracts are talking to each other and how we make that really easy. Exposing entropy, so there's a random beacon built directly into Flow and it'll be available to the runtime. It's something you can use when you're building out applications that require randomness. And upgradable contracts. As anyone who's ever built a smart contract knows, trying to get it right the first time is nearly impossible. So we're going to make that available to you right off the bat. And then, of course, the test net. So there is a test net available if you join the community. We're onboarding folks one by one, and we'll share it more publicly very shortly. But it's really about shipping community betas and your beta experiences alongside our own. We are currently in the process of building a number of experiences that Katie will allude to, and it's really important to us that we're all part of this iteration process. Everyone at Consensus I know has had the experience of trying to explain to their families why they're in this space, why they're doing what they're doing, why it's not Bitcoin, but why Bitcoin was really important, and going through that whole historical discussion. And we really feel strongly that the only way that all of us are going to rise the tide for all boats and make these experiences in this technology accessible to the masses is giving really constructive feedback to each other. So our beta is your beta. Our testnet is absolutely under development. It's something that we'll be iterating on over the course of the entire summer. It's something we want to share with all of you as soon as possible. So like I said, please join the community so we can onboard you to it. And we've also recently open sourced as the Flow and FlowGo and JavaScript SDKs. So the ability to build great experiences over the summer and be part of the iteration process that we'll be going through is available to you right now. The thought I want to leave you with is that while Flow has come a long way, I think we all have thought deeply about what it means to make this technology accessible to all. And there's a long way to go, but we're really excited for more of you to join us in that journey. So thank you very much for having me. It's been a real pleasure. And I'm happy to answer any questions if we have a minute or two left.
Cool. So I'll share my screen now. Cool. Hi, everyone. My name is Sean. I'm the CEO of Fortmatic and recently launched Magic. Before Fortmatic, I worked at Docker as a product lead responsible for developer experiences of desktop products used by millions of developers. Our new product, Magic, is a developer SDK that let users access dApps using ways they're familiar with, like with Magic links on Medium and Slack, without needing browser extensions. We're extremely excited to be building on top of Flow. But before I get into the details, I'd like to share. And just adjust my screen size a little. Before getting into the details, I'd like to share why blockchains like Flow is very significant to the next generation of internet infrastructure as well. So over the last 40 years, the internet has gone through several major transformations. Every one of them follows a similar shift in paradigm from closed, more costly, centralized systems to open, more efficient, decentralized systems. This began with the evolution from internetworking to World Wide Web, and more recently from private cloud to public cloud over decades. And today we're on the cusp of the next paradigm shift, and the need for it has never been greater. Historically, there are two forces that accelerate the end of one paradigm and the beginning of the next. The first one is democratization. Moving from siloed centralized platforms to decentralized platforms that are distributed, highly scalable, and owned by everyone collectively. The other force is automation, enabling significant reductions in cost and complexity that make brand new business models possible. And over the past 20 years, we have experienced a massive proliferation of new internet platforms that provide developers with essential services to rapidly develop applications. Today, developers can easily access services for compute, data storage, payment, and identity in ways that previous generation of developers could not. And this is the good news. But the bad news is what happened as a result. The overly centralized nature of these platforms has introduced too big to fail level of risks for developers, businesses, and users alike. Like a teetering Jenga tower, if the wrong piece falls, the entire application stack, or worse, the business, may completely collapse. The millions of developers, businesses, and users that heavily depend on these platforms are sadly much more vulnerable than they realize. The number of threats are immeasurable. A company could go out of business, get hacked, restrict availability, unfairly increase pricing, abusing power resulting from their platform login status. And if that's not enough, many companies face direct competition from the very platforms in which they rely upon. If all of this sounds familiar, it's because it happens every day. The arrival of crypto networks or blockchains, such as Flow, signals the beginning of the end of closed platform era. These distributed computer networks use consensus mechanisms, such as blockchain, to store state, to compute, and ensure availability. In modern blockchains such as Flow, developers' software code is deployed via smart contracts, almost like permanent Lambda functions, where developers now have 100% confidence that a given line of code can serve as a trusted building block in perpetuity. The decentralized nature of these crypto networks also ensures that software functions are always available, even if the creator goes out of business. In addition, developers have far greater assurances that software or platforms running on crypto networks will perform as advertised. The openness, transparency by default, and continuity of crypto networks raise the level of accountability and honesty. For blockchains like Flow, developers can not only safely depend on and trust the platforms and data that are on the network, it can reduce the cost and complexity of application development as well, while guaranteeing globally available ACID-compliant data store from achieving scalability without sharding. Today, developers can communicate with every one of these functions using standardized interfaces without having to run any servers. Yeah, the exciting part is, the the open and decentralized nature of crypto networks also allow users' identity to be portable and self-sovereign, instead of having to trust centralized providers such as Facebook. For once in the history of the internet, developers can now easily leverage one piece of technology to implement all functionalities across identity, finance, and infrastructure, enabling unforeseeable new business models. A little bit about Magic. It's super simple SDK, which you can add a Magic Link authentication experience to your application. And it includes a blockchain key pair by default. So a lot of people say it's a great way as a growth hack for the blockchain. What we are actually working on closely with Flow is a way to integrate Flow as a Magic extension. So here you can see you can add a Flow extension, and using Flow's client library, the FCL interface, without having to learn a new way to interact with the blockchain. So it's really, really easy for existing Flow developers to get started, and also be able to use the Cadence smart contract language. Also what's really cool is that Flow enables us to do smart contract accounts, because that's how Flow's account is constructed. So we could actually rotate private keys or add multi-signature, all in a very scalable and performant way, and also improve on application security. And yeah, next up, Katie Tedman will be discussing NBA Top Shot and how blockchain brings value to the NBA.
All right. So I'm Katie Tedman. I'm the VP of Partnerships and Marketing at Dapper Labs. And my background is mostly in sports and consumer-facing engagement. And so I am the right person to be talking to you about NBA Top Shot, which is the new game and platform experience that we are launching on Flow. So NBA Top Shot is meant to be a revolutionary product. And so we think that it'll be a real turning point for mainstream adoption. One of the biggest strengths of the product is the work that we're doing with the NBA and the NBA Players Association. They have a deep expertise in their own sport, and they've come to the table as true partners in building this product. And what it's done is given us an opportunity to build something that is really endemic to basketball fans. It's something that is not only officially licensed, but it's something that we think and they think will really resonate with fans of the sport. And so where do we start? So we started with the things that fans love, and those things are amazing highlights, spectacular athleticism. If you think about kind of the things that a LeBron James does every night out there on the floor, it's kind of a feat in and of itself. And some of the tribalism of fandom. So part of the fun of being a fan is having friends in your fan base, having enemies in other fan bases. And we started with what would basketball fans care about. And we tried to cram all of that stuff into these collectibles. So that is high quality video and heroic imagery. So a really multimedia experience, tapping into the thing that fans love most, which is the on-court play every night, rather than trying to abstract that away from kind of the core fan experience. Rolling game stats into there. So both sports fans and crypto fans alike are certainly interested in data and analysis and the opportunities that arise from that. And so cramming things from both ends there into the moment tokens gives us an opportunity to both play into some of the interesting things that you can do with game data when you look at who won, what kind of scoring chances happened, what happened at different times in the game, as well as the different pieces that tap into data from a crypto side, which would be the on-chain legitimacy of verifiable authenticity, maybe when the tokens are minted, what that means if you think about something that happened not last night at this time, but in the normal flow of a season. Something that happened last night maybe is more valuable if it was minted last night or this morning than it would be if it was minted a month from now. So lots of different kind of levers to pull on there, but pulling as many things that we think that fans could care about into the tokens themselves. And then creating experiences around those that serve different archetypes. And we've talked about this in a couple of other talks during this consensus event, but we learned a lot from CryptoKitties. And one of the most important things that we learned was that different players play in different ways. So we have collectors, we have speculators, we have gamers who come in and are really the backbone of people who come in and play every day. And we looked at that experience and we said, how do we make a great experience for all of those different archetypes within NBA Top Shot? And so if you think about something like the thrill of the hunt to find the thing that you want, that's the marketplace. That's where you either go to buy packs of moments or to buy individual moments in the peer-to-peer market and kind of start to put together these collections. And the joy of finding the thing that you want is certainly taps into that kind of collector perspective. There'll be kind of within the marketplace different tiers of rarity, and that taps into a little bit of the speculator market, which we're not leaning hard into but is inevitable. And if you look at the analog of something like the sneaker market or signed memorabilia, scarcity exists in the sports world in a physical space, and it will exist in the sports world in a digital space as well. And then challenges and showcases really show off your digital presence. And so this kind of plays into both of that, a little bit of that gamer mentality as well as the collector mentality, that completing challenges and showcasing your personal collection are things that bring your sports fandom into the digital space in a new and interesting way. And it's an opportunity that hasn't really existed before. And so building in those different really important loops for people to have fun, not just own their assets, but also play with their assets on a daily basis. And then also the mobile game adds that kind of utility to the moment. So if you have a great and strong collection, you'll have kind of a great experience in playing the mobile game, and it's something to aspire to and build to. It also creates an environment that's really easy for a mainstream fan to get into. And as I kind of go through this presentation, I'll talk a little more about how important it is to us to have the broad basketball fan base be able to participate in this game. But let's start with why blockchain. So starting with why we decide to pursue projects in general, our company mission is to bring blockchain technology to everyone, to mainstream consumers, to people all over the world. And so we look at audience size as we consider new projects. We have certainly had opportunities to work on really amazing projects for niche audiences, but what we're really focused on is trying to bring this technology that we all love to as many people as possible and have them feel the benefits of it. And so the audience size is important to us. The depth of fandom is important to us. We want to engage people who have a strong fan avidity, who have existing habits that make their fandom part of their daily life. And whether it's basketball, which is this case, or it's something in your life, if you think about the things you have a deep fandom for, building those connections in a digital space is kind of a natural extension to your physical experience. And then blockchain has to be important to it. If we could handle it with a centralized database, then why code in a blockchain space? And so we want to make sure that blockchain is at the core of everything we do, and that verifiable authenticity and true ownership really sits in a central place. And so sports has great analogs in it, where For something like true ownership, when you buy a jersey or a bobblehead, or even when you collect something like a ticket stub, the league or the company who sold it to you can never come into your closet and take it back from you. And so that's kind of one of the core premises that we look at when we look at Top Shot, that we need to be providing that kind of value to NBA fans. Open worlds are extremely important to us. The peer-to-peer marketplace is central to the experience. In most digital experiences, you'll get banned or your account will get wiped for participating in a peer-to-peer market, and we don't want that to happen. And then again, the verifiable authenticity of you own that thing. And like I said, digital collectibles are a lot like physical goods. And so sports fans have an opportunity now to build their collections in both a digital space and a physical space. And why does the NBA care? So this is really a question of why any brand cares. In an increasingly fragmented media environment, the depth of relationship with fans of a brand becomes increasingly important. And something like blockchain creates a new relationship between a brand and fans. So for something like the NBA, and I talk about this a lot with people in the sports industry, but it creates a new relationship between a fan and the shield, in which a fan can now interact and participate in the economy of the sport, which is a totally, like, actually kind of a radical concept if you think about it. But the relationship between something that you've invested in is different than the relationship of something that you participate in an ephemeral way. And so this new relationship between brands and fans, we think, is going to be really important in order to kind of deepen that fandom. And then of course, everyone's looking for new revenue streams and to bolster their digital presence. One thing that is super essential in the case of a brand like the NBA is to be able to service a 1.6 billion sized fan base. And we can't do that in the current environment elsewhere. And so Flow was built, as the other speakers talked about, to enable that kind of scale. And in order to reach mass consumers, that kind of scale has to exist. But also we can't compromise the vision of blockchain. And so there's some things that we need to do to make it easy to kind of enact this next wave. We have to be comfortable asking our friends to come and try things without all of the disclaimers and having to handhold them through difficult experiences. We also have to create developer environments where other people can build real businesses too, to ensure fans have other things to do. If I'm a huge basketball fan, but I'm also a huge fan of something like Star Wars, I want to have both of those experiences somewhere that I can trust and somewhere that is stable. And then having the decentralization be core to it, so that fans don't have to trust us, and that they feel the true ownership over their assets, and that if we go away, they still own those things, again, like that jersey example. And so we think that Top Shot will help to bring the next wave. There have been a lot of great projects that have already launched and that have been experimenting in the space, and those are going to kind of create a foundation. If you look at the things that we did with CryptoKitties, that Gods Unchained has done, that So Rare and Arena Sports are doing now, companies like Crypto Kaiju in the physical space, or Block Party in the experiential space. There's been so much experimenting happening, and all of that is going to set us up for this next wave. But it has to be easy to do, and the platform has to be scalable enough to have, again, that kind of 1.6 billion size of a fan base. And as more and more brands get involved here, whether it's entertainment or sports, music, we need to be able to scale further and further, but we need to do it in a decentralized way. Otherwise, why bother? And then how to get involved. So I just had to throw in a little Raptors One slide there. But how to get involved is, we have a wait list right now for NBA Top Shot. We are gearing up to launch very soon, and we'll be sending updates and information to that wait list. So if you go to nbatopshot.com, you'll be able to sign up for that.
Hello, folks. I'm Dieter Shirley, and I want to talk a little bit today about resource-oriented programming. So the So resource-oriented programming is probably a new topic to most folks. So this is just going to be an overview and introduction so that you get a sense of what it is and why it exists and why it matters. So the background here is that whenever software moves into some sort of new domain or the nature of how software is delivered changes, we need new programming paradigms. And so I give some examples of that. So in the early days of computers, computers were sort of a one-off thing, right? You know, the famous quote from the president of IBM at one point was that there's going to be a global worldwide marketplace of about 5 computers. And of course, you know, at that time when computers were such specialized equipment, every piece of software was written bespoke for that computer because they were multi-million-dollar installations. But as computers got cheaper and we started to have, you know, sort of the beginnings of commodity hardware, it became really important that code could be written for one computer and run on another, what we call portable code. Later on, we started to have relational databases in the 70s. And so the idea of being able to do atomic transactions was a new programming paradigm. When the graphical user interface was introduced in the 80s, we saw that object-oriented programming was a new paradigm that was perfectly suited for that environment because suddenly software was dealing with, you know, these virtual objects in the forms of buttons and menus and windows. And then when the web came out, we started to have client-side scripting. And this was fundamentally a different way of running software. Previously, software would be, you know, written by somebody, compiled into a binary for a particular kind of computer, and then, you know, installed typically, in some cases, in a very involved process that could take as long as hours. And that software would run very efficiently on that computer, but the setup time was very long. When we moved to the web, we wanted to be able to download these little JavaScript programs, and as time went on, even more complex JavaScript programs, and run them on any computer, regardless of what kind of hardware it was running, and to keep that execution environment efficient, but also safe, so that the code had significant limits on what it was able to do it. And whenever we saw these new paradigms become important, we saw new languages develop, brand new computer languages. And so for portable code, we saw the development of languages like Fortran and C. When we had relational databases and we wanted atomic transactions, we developed the language called SQL or SQL. Object-oriented programming led to the creation of Smalltalk, one of the very first, and of course Java, which was maybe even the most popular object-oriented programming language. And client-side scripting, of course, everyone knows is all built around JavaScript. And so when we look at software moving into the blockchain, we're talking about a new domain. So what's different about this new domain? And I think that there are 2 primary things that are different about software running in blockchains that we've seen is the ability for creating scarce assets. And, you know, we're used to thinking of assets as sort of, you know, that term referring to financial things, but of course, you know, we think of CryptoKitties as scarce assets too. And that's part of the magic of CryptoKitties is that yours is different than everyone else's. And what happens when you breed your kitties together is different than what happens when everybody else does. And that scarcity, that individuality of those cats, if it weren't protected by the blockchain, would make for a much less interesting ecosystem. And of course, it's no good in having these scarce assets if you're not able to control who accesses those assets. It's not very useful to have every CryptoKitty being different if anyone can breed your CryptoKitty or anyone can breed any CryptoKitty. That notion of ownership, that notion of having some individual control conferred by that ownership is a big part of what makes the blockchain software interesting. And so let's take a look at how we represent things in software as data structures and what properties we'd like to see in these scarce digital assets. So data structures form the basis of how software works, right? When you are building any sort of model inside a computer, you're using, you know, structured data that we call data structures. And in order to make this efficient, there's been a lot of effort gone into programming languages to make the data structures as easy to use as possible. So they're easy to create. They're typically very easy to copy and make new versions of. And when you're done with them, they're very easy to get rid of. In fact, the easiest to program languages typically have reference counting or garbage collection, meaning that when you're done with an object, you just stop using it and the system notices and automatically reclaims the memory used by that object. But of course, when we're dealing with scarce assets, especially assets of value, it's in many ways the exact opposite. We have to be very carefully controlled creation. If anyone could create any CryptoKitty, then that would completely devalue all the other CryptoKitties. If anyone could create their own a brand new copy of a token into the digital realm. And of course, you don't want it to be the case that these valuable scarce assets just disappear accidentally. Obviously, unlike the duplication or what you might call counterfeiting case, that that maybe losing these assets is less harmful to the community, but it's certainly very painful to the person who lost those assets. And so the interesting problem that we ran into when we were building our own software and we were looking at building our own blockchain is that in Solidity and in WASM, you are asked to develop these scarce resources, and the only tools you're given are the tools for managing data structures. And so there's nothing about the language that is giving you specific support for managing these scarce assets. You have power of data structures, and data structures are really valuable. I'm not saying we want to get rid of data structures, even in a blockchain context. But if you're trying to represent scarce resources as data structures, and we'll go back to this table again, you'll see that the onus falls on the programmer. Every single programmer of every single smart contract that's creating scarce resources has to take something that is fundamentally easy to create and copy and destroy, and make sure that they're very carefully putting controls around its creation. Take care to make sure that nothing about it can be copied. Take care to make sure that things can't actually be accidentally be destroyed. And so this was noticed by a bunch of researchers. And so I've got here a few different papers. And what they noticed was that there is a concept in computer programming called linear types. And linear types seem to be, these researchers identified that linear types were a much closer match to the needs of scarce resources than traditional data structures. And so let's take a look at what linear types are. So linear types, they have easy creation and make it easy for you to create them. But instead of making it so that you can easily copy them or share references to them, linear types explicitly make it so they're uniquely referenced. Then when the linear type, when you're done with it, you have to be very explicit about the destruction of it or the release of it. And so what we see here is that it's a lot closer to what we want in scarce assets. Now, the difference between uniquely referenced and uncopyable is actually pretty subtle. So yes, technically it's different, but the bookkeeping you have to do to make sure that something is uniquely referenced, and the bookkeeping you have to do to make sure that something isn't accidentally copied is almost identical. And so it turns out that linear types have a very similar set of properties to what we want to see in scarce assets. And so that was when the idea of resources was first conceived. And so what resources are is it's linear types that have more control around their creation. For those of you who are more technical, I'm using the phrase controlled creation to actually refer to very strong typing and making sure that it's not possible to change the type of a data structure and sort of create a copy of a data structure out of thin air without it going through the code that defines that data structure, defines that resource. And you need to have runtime support. So the runtime support point is a little bit subtle. So imagine this diagram here walks you through sort of the basic way that source code turns into a smart contract running on a blockchain. So you have your source code, you run it through your compiler, that produces some bytecode, which is a very compact and efficient way of representing the logic from the source code. That bytecode then gets packed into a transaction that is uploaded to the blockchain, and then the blockchain runtime executes that bytecode when that smart contract is used. And linear types are enforced by the compiler and only the compiler. Now, this is because the whole point of linear types, and the reason why linear types were of interest to computer scientists in the world before blockchain, is because linear types allow for much more efficient memory management. And anyone who's done anything adjacent to software programming knows that memory management is one of the hardest problems for software engineers to deal with. And the neat thing about linear types is that you could put the logic for managing linear types in the compiler, and you could have very robust memory management that didn't need to be in the runtime. The point of linear types was to take logic out of the runtime, where it can potentially cause you slightly degraded performance, and move all of that logic into the compiler. But in the blockchain context, that doesn't help us, because somebody who is malicious and trying to undermine your system can create a smart contract, run it through the compiler, have all of the rules for linear types enforced by the compiler, but then go and manipulate the bytecode to break those rules. And so if those rules are only enforced in the compiler, there's this window for a hacker to come in and modify the code, and you can't be sure that those linear type rules will be respected by every single smart contract on the system. And so resources need to have logic in both places. You need to have logic in the runtime, and you need to have logic in the compiler. Technically, you'd only need to have the logic in the runtime, but of course, it'd be a pretty bad compiler that didn't warn you about things that you were doing that were going to fail at runtime if it was able to detect that. And so that means that our poor hacker can't do much. They can bypass the checks in the compiler and manipulate the bytecode, but once that bytecode gets uploaded to the blockchain, the runtime itself is going to protect the rules enforced by those resources. And so now we have, from resource-oriented programming, we have the ability for managing scarce assets. Now, the second thing I said was controlling access to those assets. And it might seem like this doesn't really help us there, but it turns out, and I'm going to have to rush through this a little bit because my technical difficulties earlier, but there's a security model called the capability-based security model, or you also see it referred to as the object capability model. And it's a different way of doing security. So often when we think about security, we think about an access control list model, or ACL model, where what you can do depends on who you are. Whereas the capability-based security model is a model where what you can do depends on what you have. So it's sort of an access token model. And capability-based security, we don't see it that often because it really depends. It has a lot of really great properties, like it allows for greater separation of concerns, more flexibility. The systems tend to be much easier to audit for correctness and security holes. But we don't actually see it very often in the world because it requires special runtime support. But it turns out that the runtime support you need to handle capability-based security is almost exactly the same runtime support you need for resources. And so with very little extra work, a resource-oriented system can be also a capability-based system. And so we sort of get the best of both worlds, where we're managing these scarce resources and controlling access to those resources, all by adding this new paradigm. And so we add a whole new paradigm, resource-oriented programming, in this new domain of blockchain. And we add new languages. So resource-oriented programming has already spawned two languages, Move and Cadence. Now, some of you might be thinking, well, what the heck? I've never heard of resource-oriented programming, and now you're telling me that there's already two different languages that implement this? And the fact is that there are two, and the great part is that they're not competitive. So Moved was developed by the Libra blockchain team and is a resource-oriented programming language, and Cadence was developed by the team at Dapper Labs for use on Flow. And the reality is that they're not competitive at all. In fact, they're like peanut butter and jelly. They both have resources as a first-class type built into the language. They both are built with security from the ground up. But Move is a very low-level, efficient language that doesn't have an especially ergonomic syntax yet, whereas Cadence is a very high-level, easy to read language, incredibly ergonomic syntax inspired by modern languages like Swift and Rust. And we're working right now to make sure that Cadence can compile down into the Move bytecode so that Cadence and Move can actually work together. Move is, even though developed by specifically for the Libra blockchain, is developed as a retargetable VM and can be supported in other blockchains. And so we are looking forward to working with the Move team. They've been very open and helpful to us. And so we'll be compiling Cadence into the Move VM, and we'll hopefully be integrating the Move VM into our blockchain and get the best of both worlds, a high-level ergonomic language with great low-level efficient performance. So that's all I have. I don't know if there's any time for questions or whether or not we need to wrap up, because I think we're at the end of our time. But if anyone has a question, maybe we'll fit one in. But I'm being told that we should probably wrap up. So thank you everyone for your time. We have a Discord channel that lots of our team is in. So if you want to find that, it's linked from onflow.org. We'd be happy to talk to you there. So thanks everyone for joining the Dapper Labs team and all of the folks working on Flow. And we hope you enjoyed our presentation.